Welcome, Flat Earth Debate Special Edition Live. I'm your host Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe, hit the bell notification icon, and join button to keep up to date with the Flat Earth Debate. If you would like to support the channel, there is a super chat that runs alongside each of these shows while they are live, and there's also a PayPal, Patreon, and crypto link in the info box below the video. Now, we are joined by Brian's Logic, Neil, Refracted Curvature, and a few people in Discord who may or may not take part in this particular special edition show. And this particular special edition show has been in the making for several months, if not years, based on an argument that has been refined specifically by a few key members, including Rob, who may or may not join us today. He has been shared the link, and I was hoping he'd be here, but he may not. And our presenter for the day, which is Brian's Logic. So I'm going to introduce Brian first and foremost because he's going to be taking the reins when it comes to the actual presentation that we do today. Say we, I mean he. Hello, Brian.
Hey, Nathan. Hey, everyone. Thanks for hosting this presentation for me. I really appreciate it.
Well, I was encouraging it, so it needed a bit of spin polish and a bit of refinement, and now it's there. I'm glad that I'm the one to actually present it.
Yeah, I mean, because I don't know how long it will be, I don't know if it would cover a whole episode of Ball Busters, because I don't know if it would be a long enough presentation for that. But yet, I don't know. It depends on how many questions people might have and whatever. Yeah, it's basically a very, very simple argument. I'm not going to say what it is right now, but it's a very, very simple argument. But it's absolutely devastating to heliocentrism. That's the only way we could describe it to the audience.
Just so we don't bury the headline, though. So this argument is the circle of equal elevation argument. That's the name, or CE. What is it again? Forget the abbreviation.
CEA.
CEA.
CEA. Circle of equal
CEA argument. Right. So that's what you were going to be covering today. So although Brian obviously wants to keep the presentation's core till a bit later, I don't want to bury the headline. I want people to be appreciative of what we're actually discussing here. So I don't know if you want to lead into explain exactly what a circle of equal elevation actually is.
Yeah, a circle of equal elevation is derived from, let's just say you take an angle to a celestial body from a ship. Once you do your height of height correction, you then have a horizontal line between you and the GP point, the geographical position of that star. And that then, whatever length that is, let's say that you have exactly a 45-degree angle. That then becomes a 2,700 nautical mile straight line. And that straight line distance then becomes the radius for a circle of equal altitude. So the diameter of that circle would be 5,400 nautical miles. So, and it would be, and the circumference would be, I have to, my brain is not working now. But anyway, it would be around maybe the circumference, around 10,000 or something, or 11,000 nautical miles in circumference. But the point is that a circle of equal altitude is exactly as it says. It's a two-dimensional circle, two-dimensional flat horizontal plane. That's what it is. That's how it's measured. That's what you're measuring. So you're measuring in nautical miles an area that covers an area of in thousands of miles that covers an area that covers thousands of miles in a circle that's going to intersect with two other circles. So you do this. Sometimes they just do two. It depends if they don't need a third one. But maybe 50% of the time they'll do three circles of equal altitude. And these three circles, where they intersect, will be where the location of the navigator of the ship. So if you're lost at sea, this is exactly how you find your location using a marine sextant and the nautical almanac. So where these three circles intersect will be your position.
So we're talking about the three circles that you draw on your map when you're finding your position to try and get two, or if two isn't sufficient, three circles to overlap to elucidate your position. And we're talking specifically, the reason I keep forgetting the abbreviation is because it's either circle of equal elevation or circle of equal altitude. Now, equal altitude,
Well,
equal elevation. Hopefully it gives the game away already where we're going with this. But go ahead, Brian, sorry.
well, a more correct name for it would be circle of equal angle, because anywhere on that circle will be exactly the same angle to that celestial body as was taken at the exact time that the navigator took the angle. So circle of equal angle. And I'll explain why that's going to come into the presentation, why that is so important.
Okay, so again, if you're a bit slow on the uptake in regards to this, all of these angles are going to be taken as depicted on screen now. The Dingleberry Earth is not required, but you're going to be needing a flat baseline to measure these angles. And right on cue, we've got this description, or this depiction, I should say, on screen now, which is precisely what we will be detailing henceforth, which is these three circles. And Brian saying these would be circles of equal angles, but typically described as a circle of equal elevation or a circle of equal altitude. And that would be these circles on screen now, crossing
Exactly.
at a point that identifies your location. Okay, so hopefully we're all on the same page now, both in the panel about what we'll be talking about, if you're unfamiliar in Discord, or the audience yourselves. Please share the show. Right, Brian, I'm in your hands now. The summary has been done.
Okay. Give me. I just have to do one thing very quickly. What I will say is what I'm going to have to do is I'm going to have to share a window and then unshare and reshare another window. If that's the way I'll have to do it, because I don't want to have to share my whole screen, if that's okay. But it's okay. It'll only be a second out and in situation. But it won't be anything that, just in case anyone notices it. It won't be any big deal. I just don't want to share my whole screen, as your screen can be share your whole screen. It can be dangerous. People can copy it and use it for nefarious things.
It used to be the case. It's pretty much not the case, but I'll do some talking while you're doing some sharing. We've also, as you can...
It will only be like when I'm like, you won't have to fill in anything. It will literally. I'll share now. I'll share now. It will literally be just a moment of the screen I am sharing going away, and the next one coming in. So I'm sharing now.
Okay, so if you are in the G Plus panel, if you can just pop yourselves on mute, the time will be obvious when Brian's making his presentation. He'll lead the way in terms of inviting opinions from Discord or from yourselves in G Plus. If you're watching and you happen to join us in the G Plus panel, if you're a regular FED member, same applies. Please stay on mute while Brian's talking. We may invite your questions and answers afterwards. Okay, Brian, you've got the helm. Do you want me to stick this on nice and big?
For any of the diagrams, individual diagrams, make them as big as you can. Yeah, but as long as it's coming through clearly to the audience.
It is right. Mic's all yours.
Okay.
Diagrams up. We're ready to go.
Okay. Okay. Thank you, Nathan. Okay, this is actually the most important part to take on board here, because what I'm really going, we won't be begging the question, but we'll have to lend a certain, what's the best way to put it? We'll have to lend a certain, I suppose we won't have to lend anything much to the globe, but I just get started and be done with it. This here, why this is so important, right? It'll become self-explanatory. Is this is what you do. This is what the mathematically what they do. So this blue line here, this is a tangent plane, right? This is just reality to us. But if you are a believer in the globe and the heliocentric model, this is a tangent plane. You take our angle to a celestial body. There it is there. And down below that celestial body will be the GP point, right? Of the celestial body. Let's zoom in there. So there's your GP point, right? So, here is the celestial body. Here is the GP point, right? So what they do then is they take that, let's say here is 27-degree angle, right? And the distance is 3,000 plus here from the observer to the GP, right? They take that angle once they've done all the corrections, height of height correction, everything. They then bring it down to the center of a sphere, and that same 27-degree angle that was up here it ends up down at the center of the sphere, hijacking the celestial sphere model. But what it does then is it gives them a curved distance, right? So this is the new GP here, right? If you do that, so this was the GP here across that horizontal plane, and this down here is the new GP. And the sun or star or whatever that you were looking at, that also has to come down. Now, in celestial navigation, with the stars, as we know, you can view the same star from an airplane 6 miles above the zenith of a boat, and you will get the exact same angle to that same star. It's a bizarre thing, but it actually debunks the globe, because you can deal with it at the equator with Polaris or any other star. And if you're 6 miles above the equator in a plane, your angle to Polaris will be 0, the same way as the mariner in the boat at the equator will also get a 0 to Polaris. So that means there's not Earth curve blocking the mariner, right? That it's very self-explanatory. It completely destroys the heliocentric model. But by moving, the real point with this, to do with this presentation that's important, is when they move the angle down, what they end up having is a curved distance. Now, why I'm focusing on this before I go into the main argument here is that this means there can never be any circle of equal altitude on the globe, because there is no two problems. Number one, this means that the horizontal distance here that would create your two-dimensional circle, right, of area on the horizontal baseline of the Earth, that is now, when we move into globe geometry, that is now a curved line. So curved radii do not exist. You can't have a curved radius, because it makes no logical sense, because your circle will never match the area that resides within its perimeter. So you can't have a curved radius, because a circle is a two-dimensional thing. So whether it's a circle or a sphere, the radius can never be curved. You can't have a curved radius. You can't have a curved diameter. It has to be a straight line. That's to say you can have a curved radius, because we have people in our opposition saying this, is as ridiculous as saying as you can have a straight circle. It's the exact same thing. Can you have a straight circle? No, you cannot. So you also can't have a curved radius. So this alone destroys the use of a circle of equal altitude, because they can't have a circle of equal altitude because of this. You can't have even one. So let's say this is the initial first angle that a mariner has taken, or a pilot or whatever, and this is their angle, and they get 27 degrees off a horizontal. Once that is curved, once that horizontal is then curved, that means that you can't go any further from there. That's the end of it. If you want to start working after that point with a circle or a sphere, or with a sphere Earth, you can't go any further, because then from this point you can't get a circle of equal altitude, because you can't create a circle that's going to match the radius, because your radius is a curved line. So the distance along what you're calling a radius at that point will never match the circle that it will make on the surface of a sphere. And right, obviously enough, this is a curved line, right? So the circle of equal altitude can also be called the circle of equal angle, because from any point on that circle, the angle to the celestial body will be exactly the same. So any point on the circle is made by this 27-degree angle. Every point on that circle will be an exact 27 degrees to this celestial body. Now, that is impossible if you're trying to use a curved surface, because you can't get an elevation angle using a curved surface. You can't get it from the curved surface. That curved surface cannot be your adjacent. So it can't be done. So not only can you not have a curved radius, but you also can't get an angle. You can't create an angle and have a curved adjacent, right? So the reason I'm focusing on this so much at the start here is that just to show that alone ends the globe. Just this one part alone ends the globe. And this is not even the argument. But this one part alone ends the globe totally and utterly. So just want to say, if anyone, as I'm speaking, if anyone has any questions, just ask. Because there might be other people in the audience who might have questions. and they might have the same question, and if someone asks, then it will get answered for them, or someone listening later. So rather, if I don't know if there will be many questions, but if there is any, just ask, and I will answer it on the spot. Because I'd rather people got their questions answered as opposed to not knowing what I'm talking about and just going nodding their head and going, I don't know what that was all about. But anyway, so what I'm going to do now is I'm going to unshare that, and we stop presenting that and represent a different screen. Okay. Yeah. Now, circles of equal altitude presentation. How I'm going to do it is I'm going to go through this, and I'm going to have to get a sip of water as I'm speaking. I'm going to go through this. I'm going to have to do a bit of speaking, and then I'm going to show the physical, or not sorry, the physical, but the diagrams, right? That will, for the people who like visual learning, as I think everyone likes visual learning, that will show exactly what I'm talking about. So, circles of equal altitude presentation. So, the full official surface area possible on the globe Earth is 197 million statute miles squared, or 171,188,319 nautical miles squared. Whereas just two circles of equal altitude at full maximum size can cover a surface area of 210,822,794 statute miles squared, or 183,200,000 nautical miles squared. So if we compare the globe Earth's full surface area with the full surface area of two circles of equal altitude at maximum size, we get a globe's statute miles squared is 197 million miles squared. Two circles of equal altitude is 210,822,794 statute miles squared. If we subtract one from the other, there is a 13,822,794 differential. So that means that between the globe Earth's full surface area, the official surface area is 197 million statute miles squared. So when we subtract that from the amount of statute miles squared that is covered by just two circles of equal altitude at maximum size, which is 210,822,794 statute miles squared, there is a deficit of 13,822,794 statute miles squared. Or if we make that into nautical miles, it's 12,011,681 nautical miles squared. So these are the figures that show that just two circles of equal altitude at maximum size, which are used, and I'll give the conditions now for when they're used, is that if you're out at sea, and for those who have been at sea, I have been, when you are covered all around by cloud, sometimes the only thing you can see, the only time you can see anything, whether it be the sun or whatever, is at the horizon, right? So in the nighttime, if you're covered by cloud and you need to use a star, the only place you might be able to see them stars is at your horizons. So that's when you would use circles of equal altitude at full maximum size. Because there's going to be people out there who's going to say, but they don't do that. They do that. That's why they have celestial refraction corrections from 20 degrees down to 0. That's why they have those corrections in there, because they do use them, because they have to. So they need to be able to use circles of equal altitude that can have a radius of 5,400 nautical miles, 6,214 statute miles. They need to be able to do that. So not only can they do it, and do they do it, but I'm feeding back on someone there. Not only can they do it and do they do it, but you could never use celestial navigation from a plane, from the land, or from the sea if you didn't have the surface area that was required for your circles, because you don't know where you are, and that's the whole point of doing the circles of equal altitude. You don't know where you are. You're trying to find your location with those circles. That's the whole point of it. So you don't know, like, you can't say, well, the circle won't be able to stretch this way or that way. we don't make any claims about what the size of the Earth. The claims are made from the globe side, and that's why they are stuck with a square mile surface area of 197 million, but a statute of miles, right? But just two circles of equal altitude cover 13,822,794 statute miles squared more. So the globe basically runs out of runway. They don't have the real estate to match just two circles of equal altitude at maximum size. So the globe cannot exist, because we know that celestial navigation exists, and we know that they use circles of equal altitude at maximum size. And the reason they have the maximum size is because their sighting goes from 90 degrees at your zenith to 0 at the horizon. So they have to have that maximum size. So this argument completely ends heliocentrism. The globe model cannot exist. It doesn't have enough surface area for celestial navigation.
Okay, so I'm going to repeat.
move on.
I'm going to repeat the most important statement on screen now. There is a deficit between the globe model and two circles of equal altitude full surface area. Then you've got the maths laid down on the screen in front of you now, so you can see exactly what Brian's already done in terms of the mathematics if you want to nitpick over his maths. However, if we subtract the nautical mile difference between the globe and just two circles of equal elevation, there's the deficit. So there is a deficit between the globe model and just two circles of equal elevation when taken at full surface area. That's the main point that is being made in this show. I just want to repeat it. It's up to you, Brian, but it might be a point to open up at least to the guys in G+. See what they've got to say. It's up to you.
What I'll do is I'll actually go through the whole presentation. I'll leave people say something then. It's probably easiest because there's more to come. And it's cool. We're moving along pretty fast, so this might be probably the best way to do it. Right? So we move on down. So this alone, as we just stated, Nathan, there's over 13 million statute miles, right, of a deficit between the two circles of equal altitude at maximum size and the globe model. Or over 12 million nautical miles squared between the full surface area of the globe model and just two circles of equal altitude at maximum size. It cannot exist. It's an impossibility for the globe model and heliocentrism to exist if celestial navigation exists. And it does. So if celestial navigation exists, P, then Q, the globe model can't exist. P, celestial navigation does exist, so Q, the globe model can't exist. That's about the size of it. But so far we have only compared the full surface area of just two circles of equal altitude at maximum size with the full official surface area of the globe Earth. But if we look at a comparison between the full official surface area of the globe Earth model and we compare this to the full total surface area possible with three circles of equal altitude, including the overlap of the third circle taken into account. I'll show that in a minute, but that basically on the third circle, you can make two circles of equal altitude where they will butt up against each other and they won't overlap, but the third circle will always overlap. So if we're taking that into account. So including the overlap of the third circle taken into account, we get the globe's full statute mile squared area equals 197 million square miles statute. Three circles of equal altitude, full size, a statute mile squared is 277,956,602 statute miles squared. In nautical miles, the globe's full surface area covers 171,188,319 nautical miles squared, whereas three circles of equal altitude, including and with the overlap accounted for, will cover an area of 241,537,684 nautical miles squared. So 277,956,602 minus 197 million equals 80,956,602 statute miles squared. Three circles of equal latitude and maximum size with overlap included is 80,956,602 statute miles squared bigger than the total surface area of the globe Earth, or 241,537,684 minus 171,188,319 equals 70,349,365 nautical miles squared. Three circles of equal latitude at maximum size with overlap included is 70 million, that's 70,349,365 nautical miles squared bigger than the total surface area of the globe Earth. So, ending the heliocentric model for good. There is no way back out of it. The globe is too small. That's about the size of it. Now, what I'm going to do is I'm going to unshare this and reshare another screen. So I'm stop presenting here. We share here now. And I'll show some diagrams. Okay. So now I've erred on the side of caution as much as possible. So I'm going to explain these diagrams. So these top two ones, the red and blue ones, that is just two circles of equal latitude, okay, at maximum size, right? And down here, this is the these kind of lilac and burgundy ones. That is the maximum surface area of the globe broken into two and placed into two circles. So just two circles of equal latitude here. I have a box going around them. I have a bit of a thing up here I'm trying to get rid of. I have this red box going around them. As you can see, there is deficits at the sides here. This is all the area that the globe surface area can't cover, right? So this here, I have the box touching the sides of these two circles, and I have the radius of this one here in an exact line with the radius of this one. So this is showing the deficits that's at each side, right? That is all the area that these two circles that are representing the globe's 197 million square miles covering. That's what these two are representing. These
I don't understand. You're going to have to go through that again. Stop. Sorry, Brian. Please go through that again.
Okay. Yeah, I have these two circles at the top. They are representing, right, two circles of equal latitude on a flat plane, on a horizontal plane, right, as measured, right, two-dimensional. These two circles down here, what these are is these represent the full surface area that if we flattened out the globe and made two circles out of the total surface area of the globe Earth, these are the two circles that represent that. So two normal circles of equal latitude at maximum size here up top are bigger than the full surface area of the globe, which is down here, flattened out. So if you imagine this is as big, this is the maximum size if we use the full surface area of the globe Earth, and we wanted to make two circles of equal latitude out of them on a flat plane, this is the maximum size they could be, and are way smaller than these two up here. And these two are the size we use in reality. So these are too small for reality. Even if the globe was a flat plane, even if it flattened out all that area, it still wouldn't work because there isn't enough surface area. So
okay, I'm with you now.
Move on.
Yes, now I follow now. It just wasn't quite clear at first.
Yeah, I didn't add in the caveat, one or two caveats. I'm sorry. So this is the next one, right? So this is three circles of equal altitude, right, with one overlapping here, right? This is what size it is in reality with an overlapping. Well, obviously this yellow one would be overlapping here. This is the full surface area of the globe Earth made into three circles of equal latitude. If you flattened out the surface area of the globe Earth, 197 million statute miles squared, if you flatten that out, this is the amount of surface area. If we made three circles of equal latitude out of them, this is the amount of surface area that it could cover. So this up here is reality, whereas this is the best the globe could offer, even if it was flattened out like a pancake. That's the best it could offer, these down here. This is way bigger than this. But this up here is reality, right? Just to make it even more bizarre, here we have the same two again, right? But this down here, this just so people can get some kind of a visual picture of it. These here are the equator size of the globe. So if you made just, right, this wouldn't cover all the globe surface area, but if you made 3 circles of equal latitude at the using the equator of the globe, this is the size that it would be in comparison to what we use in reality. And this here would be the maximum surface area in the middle that the globe flattened out could cover if you wanted to make that, take that whole surface area and make 3 circles of equal altitude out of them and overlap one. This is the biggest it could be. So up here is reality. This is the maximum surface area of the globe Earth, right? It flattened out and made into 3 circles. And this here would be what 3 circles would look like of equal altitude if you just use the horizontal plane of the globe and their circumference size. So look at the differences. Up here is reality. This is what can't match reality, and this is what we don't use in reality. So just to give it a little bit more, right here. So there's no overlap. So here you have at the top, this is just 3 circles of equal altitude at maximum size. Here they are, these 3 here. And this is a comparison with taking the full surface area of a globe Earth and making 3 circles out of them. This is this comparison in size. Up top, we have reality, and down here, we have the best that the globe Earth could offer, even if it was a flat plane. This is the best they could offer if they wanted to make 3 circles out of the full surface area of the globe. That's the best they could do. Whereas up here, we can do this and more because we have no idea how big the plane is. We don't know how big the Earth is. All we know is we can always use these 3 circles, always at maximum size. And that is, except for one thing, for people to remember this, they can't even get a circle of equal latitude on the globe because you can't have an equal angle to the celestial body because you're using curved surface. As soon as you move your angle to the center of the equatorial center of a globe, and you would then have a curved radius, so none of it works anyway. But the point is that even if you somehow could flatten out the globe, you still couldn't do it. There wouldn't be enough surface area. That's the end of the presentation.
Absolutely epic. So the globe has insufficient surface area to cope with the navigatable area that we can actually measure and navigate. The globe's too small. It doesn't have enough surface area.
Yeah.
That's what I just said to somebody in chat because they said they missed it. That's the basis of the whole thing, what Nathan just said, correct?
Yeah, there's over 70 million nautical miles squared missing. Or over 80 million, if you want to make it bigger, over 80 million statute miles squared. Over 80 million missing. So the globe is missing over 80 million statute miles squared.
Perfect. I'm going to do a couple of quick shout outs and then hopefully you can recover your composure and figure out what you want to do with either Discord or the G Plus panel going forward, Brian. Shout out to Rene Kalseka. Hopefully I'm saying your name correctly. Nathan, best globationist on beautiful flyer. Thank you very much for the compliment. I really appreciate the support. Also, shout out to Mr. S, who sends me a super sticker, says, good job. The timing for that super sticker was as Brian was dropping the bombshell, just so we're all clear about the timing of that particular super chat. And also shout out to Rich P. I really wreck my back over the holiday weekend. Man, it's so good to have this night show. Thank you. It's our pleasure. It's certainly my pleasure. This is epic because this is has been discussed for quite some time. So on the eve of the death of the Queen of England, after 70 years on the throne, Brian has released the information in regards to the deficit that is the heliocentric globe Earth model. It simply doesn't have enough land mass to cover the navigatable amount of land that we actually experience and can measure. Excellent work, Brian.
Thank you, Nathan.
And everyone else, can you just maybe rattle off a few, maybe give some, credits?
I got help off of Adam and obviously John, refractor curvature, and off Mitchell and off of Rob Durham, um, and QE too, QE and obviously 10th man, right? Obviously 10th man because he brought the whole. Although he wasn't the first to suggest it. He did all the research. QE was the first to suggest it, just after the Black Swan. But 10th man did all the research. He brought all this information to us, and people like me just took it and did things like this with it. But basically, it wasn't like a solo affair. It was my idea, but that doesn't mean that it's all mine because everyone was involved, and I needed help from other people to do what I did. So I'm very happy that they were there to help because it would have made it a lot more difficult. And just so people know, Rob Durham made some things for me, but there was calculations that had been given to him that weren't correct. And even Adam might try and correct me on these calculations later. But what I did here for people to know would actually only error on the side of the globe. That's what I did with my calculations. So any calculation that is wrong will only be worse for the globe. It can only be worse for the globe. It can't be better. It can only be worse. The globe can only get smaller in surface area. But I don't think I did that wrong. Anyway, I think everything is correct. But if I did that wrong, all I did was make the globe too big.
Oh, I'm pretty sure
they'll see that means nothing.
Well, let's cover that. We'll come back to that. John, have you got anything to add? We've heard a bit of commentary from Neil, and he's obviously been reiterating the point in chat. So thank you for that, Neil. But did you have any points to add before we come to that exact point by Brian about the T's and the I's and the commas?
Well, what does it mean if the claim of geometric size of the Earth is too small to cover the amount of area that we experience it? What does that mean, Brian?
Well, it means that the Earth is that we're told we live on has to be that claim has to be wrong because it's too small. But it also means that it has to be a horizontal plane, have a horizontal baseline, be flat, because all these measurements are being done with the pre-assumption of a flat plane, horizontal plane in mind. So when you're making these measurements, you're using the horizontal baseline of the Earth, where all elevations are taken from, the flat plane of the Earth. So it not only does it mean that the former claim of the Earth having a maximum surface area of 197 million statute miles squared, not only does it mean that that's completely wrong, but it also means that it can't be a globe. So if it can't be a globe and the surface area is wrong, then if you understand the heliocentric model, it means all of heliocentrism is finished. Because everything in heliocentrism is based off of it being a globe with a radius of a particular size. But this proves none of that is true.
Did you want to add something to that, John? If not, I'll do a quick super chat shout out.
Well, I think it's important to remember that, like, he's giving them a lot, and it's still not working. You know.
Yep.
That's a pretty big deal.
Yeah, Omega Werty from the super chat says, at best you've disproved our bigger globe. Lol. Maybe we'll come to that, but I just wanted to address what you said a moment ago, Brian, before you move on. So you said if people can find flaw in what you've written down and what's been presented here, mathematically or otherwise, I assure you that'll be the first thing they'll try and attack. But from what you discussed with, I can't remember if this made it to the pre-show or not, if it was before or when it was discussed, but in any event, we were discussing this and you just pointed it out in terms of how you've erred on the side of caution in most instances, if not all instances. Therefore, if there are errors, it'll be in their detriment if they were to correct those errors, if there are any. Now, do you want to expand on that before you go on to the point you're about to say, if I haven't made you forget it?
No, I will. They're similar. I'll expand on that and then I'll make the point. Yeah, if there's anything that's wrong, it'll only make the whole. It would only change let's say these diagrams. It would only change the calculations and the diagrams for the worse of the globe. It would only support us better. So I erred on the side of caution as much as possible to give the globe, like I can only give it 197 million square miles. That's the most I can give it. That's the maximum that it can be. Right? If you do the maths, that's the maximum it can be. Or 171 million, 188,000 something, 319 nautical miles squared. That's its maximum. It can't be any more than that. So I did my best to make sure that I represented that size as best as I could. Now, I might have over-represented it, and that's my point. So if there's anything wrong, it will only be worse for the globe. So if they want to nitpick through it, they will find out that it's only going to be worse. The point is, it doesn't matter, because in the end of the day, they have a maximum size of 171,188,319 nautical miles squared surface area real estate on our model. 3 circles of equal altitude and maximum size is 3 circles of equal altitude and maximum size is where is it? Yeah, it's 241,537,684 nautical miles squared. And that's including the overlap. It's actually more. It's actually 274 million. So 3 circles of equal altitude. If I just show this again, this is actually like if we don't add the overlap because it isn't in this diagram, then it's 274 million, if I remember correctly. So it's actually without the overlap, it's way bigger. You know what I mean? So the surface area covered by these 3 circles here is 274 million and more and thousand more square miles. You know, statute miles, or sorry, nautical miles. But the point is, it doesn't matter what they do, because they can never be any more than 197 million. That is the maximum that a sphere of that exact size can be. It can't be more. Well, there's absolutely no way out of this.
Based on your presentation, that when you started it, you were explaining that if you take 2 circles at maximum, that will exceed the maximum surface area of the sphere Earth. Just 2. So that's it. Did you want me to open up this discussion to the people who are in Discord?
1 second now. 1 second. I just want to show something here before we open up the discussion. Okay. 1 second. Just so people can see it. So 2, right? So just using 2 circles of equal altitude at maximum size, just 2 will have a 13,822,794 statute miles squared surface area greater than the maximum surface area of the globe. That's just 2. Not even the third one added in, just 2. If we use the total surface area of 3, right, including their overlap, so this is including the overlap, so we're accounting for that overlap, right? There'll be an 80,956,602 statute miles squared deficit. You can't go past that. The globe surface area will never be any more than 197 million square statute miles squared.
And it's not enough. That's the bottom line. That's not enough to cover the area that we're going to be measuring when we're doing navigation. That's the bottom line.
So you mean to tell me that these bastards got us living in a closet when it's a mansion out there?
It's a good analogy.
Are you kidding me?
Yeah, it's a good analogy. Because we don't, like, the 3 circles of equal altitude that I had up on the screen a minute ago, that doesn't mean that's the maximum size of the world. We don't know what the maximum size is, but the globe has a maximum size. And just for anyone out there who doesn't understand heliocentrism and doesn't understand why the globe is that size, the globe, you can't state it might be a bigger globe or a smaller globe. You can't. It has to match the observations of the sky. And if you change the size of that sphere, then the observations won't match within any computer program. You can use stellarium, anything you want.
I just want you to reiterate that. So what Brian's saying, and I want you to repeat it, is that your radius value is set in stone. It's a back calculation from the observation of the stars and will not and cannot be changed. The heliocentric model, as the size goes, cannot change. I just want you to reiterate that point, Brian, if you don't mind. Just say basically the same thing again.
I'll actually give the history behind it, Nathan. The heliocentric model, the globe Earth model, its radius is a back calculation of flat Earth elevation angles to Polaris, which gave us our latitudes. That means that for the globe's radius to be a different size, whether it be bigger or smaller, means that geometrically that would mean the globe would never match those latitudes. Now, it doesn't match the latitudes anyway because they have an added 7/6R added in at all times and more than 7/6R refraction, which means that the horizon that they were using would never match the latitudes anyway. But that's a kind of a separate issue. The point is that it can't, for the latitude and longitude grid to match the globe as it is, and for all that to match the sky as we observe, then the radius has to be 3958 and change, rounded off up to 3959 miles, 3,959 miles. It can't be less, it can't be more. That's why they're stuck with that and with a total surface area of 197 million statute miles squared.
Okay. Well, we've got Mitchell from Australia, so I'll just say a quick hello to Mitchell before I pipe up with my couple of comments, if that's okay with you, Brian, and then perhaps we'll hand over to Discord. Hello, Mitch.
G'day.
G'day, sir.
Presentation, Brian.
Yeah, it was great, wasn't it?
Yeah. I've just been doing a few calculations on the back end of this, Brian. Is the presentation pretty much over? Is there comments yet?
Yeah, walk away. It's finished. We've gone through it.
We're into the bit where we get your comments, actually, Mitch, so very appropriately, go ahead.
Brilliant, because I just have to pull you up on a few calculations, Brian. When we were going through this, I said you can't convert from nautical miles squared to statute miles squared. You can't do that conversion. You have to do it from the base radiuses of each of them. And in doing that, it actually makes the discrepancy between the total surface area of two circles of equal altitude and the total surface area of the globe far worse. So,
excellent. So good timing. So what Mitch is saying is, based on his discrepancy, this is why this has taken a while to come out, because we know that the only criticism will be in regards to how the maths is done. But in this instance, what Brian's done is taken all of the criticisms and gone to the very edge of what he can conceivably give the globe. But what Mitch is saying is, no. But you can't do it in that calculation because the cross conversion from globe statute to flat nautical, is that correct? Mitch, can you reiterate your point?
Yeah, it's far worse. You can't convert straight from nautical miles squared surface area to a surface area of miles squared. It's a very hard conversion. So you have to start at the base of this. So and surface area for a sphere is 4 pi r, and so that gives the total surface area in nautical miles squared of a globe 148 million nautical miles squared. The total surface area of two circles of equal altitude, which is one circle would be pi r squared for one circle. So two circles of equal altitude with a radius of 5,400 nautical miles would be 183 million nautical miles. So if you take 183 million from 148 million, I think I've said that backwards, 183 million, take away 148 million, gives you a discrepancy of over 35 million nautical square miles. And that is a massive difference. I think he quoted it as maybe 13 million nautical square miles discrepancy, Brian. After doing the calculations, I worked out it's far worse. And to put that in statute miles, because not many people work in nautical miles, the total surface area of a globe in miles is 196 million. So that you had that correct, but you try to convert it to nautical miles straight from that. But the actual total surface area of two circles of equal altitude in miles squared is 242 million. So 242 million miles squared, take away 196 million miles squared leaves a discrepancy of 46 million miles squared that the globe is missing just from those 2 circles of equal altitude. So it's far worse. I was trying to look
It's
up.
not missing. Just let me get the
like-
terminology right. It can't account for it. It's a deficit. It's not missing anything.
Yeah,
it's
the
got a
deficit.
certain surface area, and the maximum has been breached by the amount that you can actually look out and draw a circle on a map with. So it's got a deficit.
So that screen there at the moment. So Brian, you had 13 million nautical miles squared deficit. It's actually 35 million nautical miles.
Yeah,
And
Oh, here we go. Hold on.
John, go on.
No. I want you to respond before John goes. Sorry, John. Go ahead, Brian.
Yeah, what I did, and I knew this would come. I knew that Mitchell would put me on this, and I knew Adam would put me on it. Is I took the 197 million statute miles squared, and I just converted it to nautical miles, which gave me 171,188,319 nautical miles squared. And I have the calculation from Mitchell that he did, and I had that calculation, but I did it this way because I wanted for somebody to come in to correct it. Well, like, I'm not talking about Mitchell, I'm talking about somebody from our opposing side. And when they go to correct it, it turns out that it's much worse for them. Because it doesn't matter, because they are stuck with 197 million statute miles squared of a surface area. Whereas we can cover that with just 2 circles of equal latitude at maximum size is greater than that. Even 2 circles of equal latitude smaller than that is greater than that.
Okay, and that's the bit I want to reiterate, because before we get lost in the numbers, thank you for clarifying that, Brian. There's a deficit. That's all that matters. 2 circles of equal elevation are greater than the surface area the globe has to offer. That's the brass tacks of what we're dealing with. I just want that to not get lost in the numbers for the audience. So, John, go ahead.
And 3 are much worse.
Obviously, 3 are worse, but because this is the bit we've bandied around for quite some time. Can it be stated as I've just stated it? And it can. Okay, that's the nitty gritty. Go ahead, John.
I was just going to say, I don't appreciate Mitchell coming in and completely destroying where I have fallaciously argued for more surface area to the globe, along with all the hard work that Adam put in, trying to just squeeze a few extra inches. That's messed up.
Okay, we might get into that in the after show. I mean, the fun that's been had in the weeks leading up to this presentation, which you can probably hear from my smile. I'm very pleased this is now out and it's there, right? The critiques will come, you know they will, but the information's now been presented to the public, and I'm elated about that fact. And you've done a really good job of it, Brian. Now we will probably, John, get into the wrangle dangle that this is, you know, that has come before this, the preceding wrangle dangle. Like I say, but we'll do that in the after show. But I would like to open up the mic at some stage to the public, because typically that is the case with any flat Earth debate, Brian. So if it's okay with you, I'm going to do that now. And it may be just tumbleweeds. You never know. There's been a couple of people joined since I last attempted to introduce them. But if it's okay with you, I'm going to open the mic and invite their comments and opinions. But I'm going to lead in with hopefully a remark from someone in Discord, which was in regards to an old, I think it was sort of pre-Cook in terms of the descriptions in these books, and maybe 10th Man can verify this, but Paul, the guy who contributed the majority to my new PC, which is coming imminently, pointed out that the area beyond the horizon in this regard used to have a name. Now, maybe this will spark Paul to pipe up, but can anyone guess what the name of the area beyond these circles that we've been discussing in the show might have been called in days of yonder? Can anyone guess from the G Plus panel?
Haven't got a clue.
Outer space.
Oh my goodness.
Very good.
Did you catch that? Outer space. The outer space is the area beyond these circles of equal elevation at maximum altitude that have been mapped and plotted with longitudes and latitudes. What's beyond? Well, outer space was what it used to be described as. I just thought that was a nice segue into getting the opinions and comments from the Discord server. Okay, so thank you, Paul, by the way.
Well, here's another aside to that same line of thinking, which is...
you're breaking up a
So-
little bit, Abstruse. Can you maybe get a bit close to your mic? I don't know if there's some...
I'll start over. Hold on.
while we're waiting for abstruse, was there anybody else who's going to get in the queue?
Can I just reiterate how much deficit there is in the size of countries?
If you keep
So
it,
Russia has-
keep it to the minimum numbery bit, but just to keep most of the audience intrigued.
It'll be very easy. I'll keep it to countries. So Russia has a total surface area of 6.6 million square miles. So the size of Russia. Russia's the biggest country that we know of. There's a discrepancy of 7 Russias between the total surface area of the globe and 2 circles of equal altitude.
That's epic.
7
That
Russias.
was absolutely brilliant. That's great. If you can describe it in Russias, then people can comprehend what we're talking about. That was great. Abstruse, can we just get a check 1, 2?
1, 2.
Okay, yeah, I think we've got you. I'll just turn you up a bit. Go ahead.
Right. So in the heliocentric expanding universe paradigm, the universe is actually expanding faster than the speed of light. And because of that, galaxies or whatever the heck is out there, well, we will never be able to see because the light can't reach us no matter how hard and how fast it goes, right? Because space itself is going faster than the light. And so where that light can reach, right, where we can see it, then all of a sudden we can't see it anymore. They refer to that as the horizon.
In space terms, they call that the horizon.
Right. It's where the light can no longer be seen. Is the horizon.
Beyond the redshift, so to speak.
You could look at it that way.
Okay. Very good. Has anybody else in Discord got any comments quite specifically in regards to the globe Earth landmass deficit and the 2 circles of equal elevation that exceed at maximum measurement the total surface area of the sphere Earth model? Any comments from Discord?
Yeah, just to be extra critiquey, because I might have missed this because I was driving. Did you count for the differential of the overlap, like the Venn diagram?
Perfect question.
Yeah, we counted for the third circle, which would overlap. The first 2 would butt up against each other, but the third one, you can make them butt up against each other, but the third one will have an overlap, and we accounted for that. So we didn't even give the full size of the 3 circles.
Did you follow that, Abstruse?
Yeah.
Again, we're going to get into this in the after show because, again, there was a few points like this that just dragged out this process. But good critique. Any more for any more? I'm hoping we'll get some. Go.
I just want to say that me and Adam fought really hard to get it up to 197 million. Like, that was a hard fought. Like, and just for Mitch to come in and point out that that's wrong, it hurts my feelings.
No, that part's right. That part's correct. If we're living on a globe of radius 3959 miles, the total surface area of a globe would be 197 million statute miles. That's correct. You can Google that. What's the total surface area of the globe? 197 million miles. That's correct.
Yep.
It's the part where you convert to nautical miles or vice versa. That's the discrepancy.
See, I had us living in a closet before. After Mitchell, this son of a bitch has got us living in a shoebox when there's a massive estate out there. Huh.
Yeah.
And with that, I'm going to say, if you are watching this on either Nathan Oakley 1980 or Nathan Oakley premiering streams, then stay tuned, as there will be an after show in this regard. Unfortunately, though, if you are watching this live, this is where we bid you farewell. I think there was one extra super chat that I didn't actually shout out properly, so I will do that now. Shout out to, here we go again, who says, I'm working again for now, lol. Cherry Coke Money, enjoy. And many thanks to you and the panel. Our very appropriate super chat to end on. So another massive thank you to all of you. Smashed the super chat, liked, commented, shared, subscribed, joined as a Nathan Oakley 1980 channel member and all that good stuff. Smash the thanks button after the fact. Stay tuned if you're watching on an after show. I've been Nathan Oakley and I'll see you all in the next video.
What a lovely day!